Okay, take it away, Rachel.
Oh, hey everyone. Thanks for joining us for the February edition of the audio program on Meetup. I don't know about you, but I feel like January was everlasting, and I'm quite glad to be in February myself. So, you know, other people are feeling the same, and days are getting a bit longer here in the UK. So that's always welcome. Tonight we have two guests. Well, we have three guests, including myself, but we have two extra guests. We have Adam Wilson and Ale Koretsky, who both have some interesting talks lined up for us today. And my name's Rachel, if you haven't been here before. I co-host this meetup on the second Tuesday of every month with Joshua Hodge. How are you doing tonight, Joshua?
I'm doing great. I hope everybody's doing well as well. We have a worldwide contingent of people joining us. So thank you very much to Adam and LA for joining us. Some really nice talks on entrepreneurship and figuring out your own path in audio software development or otherwise, and also talking a little bit about AI and machine learning, the current landscape that it has in audio. Obviously, every day there are new advancements and new developments that are happening there, and Ali has been part of those developments and also has a lot of experience in this field, and he's going to share his experience and perspectives on that. Before we start, just want to make a couple announcements. There are quite a few exciting things happening in our world at the moment. So I'll just share my screen. First thing is that I wanted to talk a little bit about Dante. They're holding a sound and software challenge. And basically what they wanted to do is hear your ideas around audio software applications and networking. So if you have any ideas, they have over 7,500 for the first prize and $1,500 for the third prize. So it's a chance to win some money. And what you can do is you can enter this Sound and Software Challenge. The link is actually in the video description at the very top. So I hope that you have some great ideas for this and you enter. Another thing is that we have, as you know, the Audio Programmer has a recruitment and contracting agency, and we have two critical contracts that we're looking for contractors on at the moment. One is for a JUCE and C++ contractor, proficient in graphics programming and UI. So if you have experience with OpenGL, Metal, Vulkan, and with building complex JUCE user interfaces, and you're available for contracting, get in touch with us. We also have another contractor role for somebody that has experience with Yocto Linux distributions, build systems, and large code bases. So if that sounds like that's up your street and you want to come have some development fun with us, please get in touch with myself or with Tessa. And we will be happy to talk and see if we can work something out. Also wanted to give a big thanks to our sponsors, Sonnox and Focusrite, who are sponsoring the Audio Programmer Meetup. Without you, these meetups would not be possible, so thank you to Sonnox and Focusrite. And with that, I will pass the mic back to Rachel, and she will introduce our first speaker.
Great. Thanks, Josh. So our first speaker today is going to be Adam Wilson. Adam has over 15 years experience in the audio developer space and is the founder and chief of Node Audio. And today, Adam will be speaking to us about how he navigated the journey from audio dev to entrepreneur. And the goal of this talk is to inspire others to follow their dreams and take the necessary risks to get there. So I think we can all benefit from this talk today. I'm really looking forward to it. When you're ready, take it away, Adam.
Thanks, Rachel. And yeah, thanks, Josh, as well for inviting me to be here. It's an honor. My first time on the Audio Programmer. Yeah, so as Rachel just said, yeah, my aim with this talk, which is also going to have a bit of interaction, which is a bit of an experiment, is to inspire people to really follow their dreams and kind of work out what their dreams are as well, and then work out what steps they need to take to really get to or towards what they really want to do, and then to give people some of the courage necessary to take the risks in order to get there, because that's something, it's one of the big things I've been learning in recent years, is that to get where you really want to go almost always requires some risk taking. So what I'm going to do is in the first part of this talk, I would like to make it interactive. And this has come, this technique I'm going to use has come from some coaching that I've had, actually from a guy called Mike Monday, whose courses I've been on, and I've had some coaching from him in the past. And it's a technique he uses a lot in his teaching, which really helps to drill down and sort of dig into the subconscious of like, why are you doing what you're doing, and where do you really want to go, and where do you want to be in a few years' time. And so I'm going to get into this, and then after this exercise, I'm going to get into my story. So I'm going to tell parts of my story, going from a hobbyist to freelancer to business owner, and my current journey getting into being an entrepreneur. So this exercise, it's a free writing exercise, and what that means is you write until the time ends. So there's going to be just two questions really, but the second question is going to have lots of questions within it, and I'm going to give just over 1 minute for the first question, and the second question I'm going to give 5 minutes. So what I'd like everyone to do that's up for taking part in this is grab a notebook and a pen, or load up a notepad app, or whatever you want to write on, and get ready to just write, just splurge write. And the idea with the free writing is you keep writing until you can't think of any more to write. And at that point, you repeat the same word until more stuff comes. And so this is, it's a cool technique to sort of kind of tap into the subconscious. And the way, one of the really powerful aspects of this exercise is, in my opinion, it taps into some inner wisdom that we don't always have access to. So anyway, let's get into it. So so maybe if you get your writing materials or your notepad app ready, and just to be really clear, so Josh and Rachel did speak about this just before we started. A very, very important point is, don't write it into the live chat. Very important. This is just for you. So just write it down, on whatever's comfortable, but not in the live chat. Later on, if you want to share some interesting stuff that came up, then feel free to write that in the live chat. But let's not fill the live chat with random streams of consciousness at this stage. Okay, so let's get into this. So the first question is, and I'm going to set my timer. And there's going to be a little beep beep when the time's up. And here's my timer. If you can see it, I haven't got an extra camera, so I'll just maybe I'll show it when it's coming up to time. So the first question is, why did you start doing this in the first place? So I'm assuming that most people here are at some point in their journey as an audio programmer. So you might be just learning about this stuff, you might be a student, this might be a hobby for you, or you might be a freelancer, or you might have a business, in various levels of maturity in this industry. So my question is, why did you start doing this in the first place? What was the thing that got you into this? And what drew you to audio software programming specifically?
You're supposed to be writing right now, just in case you're wondering what the silence is for.
Yeah. So I'll repeat the question. Why did you start doing this in the first place? What drew you to audio software programming? And why are you here? Why are you watching this? What was the moment that made you decide this is what I want to do? This is what I'm interested in. This is my thing. When did that happen? So there's about 5 or 10 seconds left. Oh no, there you go. No seconds left. So yeah, just finish off what you were writing. And yeah, I should have reminded you that when you can't think of any more to write, just repeat the same word over and over again until more stuff comes through. This might be relevant for the next one because it's a bit of a deeper question with kind of lots of sub questions within it. So the next question is, where would you ideally like to be in 5 years' time? What would you like to be doing? So I'm going to give this 5 minutes starting from now, and I'm going to give you little sort of prompts to help you along the way. So we're starting the 5 minutes now. I'll ask the question again. Where would you ideally like to be in 5 years' time? What would you be doing?
I've written this question in the chat as well for anybody that's
Thank you, Josh. Thank you, Josh. Yeah. So what does your day look like in this, this ideal life that you're living in the future? Where are you? Where are you living? What are you spending your time doing? What's your vision? What can you see? And who are you with? And imagine, and I really encourage you to think big. Imagine you had all the resources you needed and you could not fail. So really think big. You've got all the resources you need and you cannot fail. And remember, if you can't think of any more to write, just keep writing the last word over and again until more stuff comes through. So in this, this ideal life that you're living, who are you serving? Who's your ideal customer or client? Or maybe you don't have any customers or clients. Maybe you're doing something completely different. Maybe you're making music. And through what you're doing in your ideal life, how are you affecting the music industry? And how are you changing the landscape? how will you challenge the audio industry? What's the gold that you're bringing to the world? That unique thing that you are here to do. That only you can do in your unique way. So we've got just under a couple of minutes left. I'm just going to repeat some of the prompts. Hopefully it's helpful. And just keep writing, don't stop. So where would you like to be in 5 years' time? What is your vision for yourself? For yourself and for your family, maybe for your community? And what does your day look like? And remember that you have all the resources you need and you cannot fail. So we've got about 30 seconds left. So I'm up to time. Okay, so that's 5 minutes up. So when I've done this exercise before, I've personally found it super powerful. And what often surprises me is there's unexpected stuff that comes through. Because you're not censoring yourself, you just keep going, and stuff will come out that you might not expect. And it might be, there might be some stuff in there to chew on that could help you make some good decisions about where you want to be going. So yeah, maybe, I'm now going to get on to talking about my journey. But if you feel inspired to, you're welcome to share in the chat anything that came up. And I think there's going to be time for Q&A as well. So, that you have the opportunity to share anything that came up for you during that. So I'm going to now get on to the second part of my talk, is talking about my story and some of the things I've learned and some of the questions that have come up for me. And this is kind of continuing on. I don't know if any of you were at ADC and were able to attend the panel on starting a business in the audio software industry. So we were given a bit of an opportunity to talk about this, and I really wanted to expand and talk about some of the stuff that there wasn't time for during that panel. So I'm going to just start talking about my story now. So I started programming around the age of 13, and I got a friend of my dad gave he saw I was into computers, and my parents, you know, I was messing around with BASIC on my mum's computer, and then I had my dad got me a PC, and this friend of the family saw that I was interested and sent over a C++ compiler, the Boolean C++ compiler. And so I was really into this. So I just, you know, dived into this reference manual and learned C. I didn't get into C++ at that time. My dad had the Kernighan and Ritchie book on the C programming language. That was my reference manual. I don't know if any of you remember that. And I got really into that and got another reference book on MS-DOS interrupts. So I had a lot of fun with some low-level programming, and got into some low-level graphics programming, which was quite fun. And then at the age of 14, I got into making music. In the early 90s, got into electronic music making I was really lucky at my school. They got some Atari STs and Roland D5 keyboards. So I got really into that, got into listening to pirate radio, going to parties when I was allowed in. And I left the programming. I kind of left the programming behind. I thought it was too nerdy, too geeky. I'm a cool kid now. So yeah, so then for a long time, music and programming were separate things. So I was, I continued to produce music for many, many years, and still produce a bit now when I can. And programming was what I did for work. So I went to university, studied AI and computer science, and then got a job as a web developer. So for a long time, these two worlds were very separate. And then about 8 years ago, oh yeah, sorry, Rachel, I have to correct you on your one thing in your introduction. My experience in audio programming specifically is about coming up to 7 or 8 years now. But my general programming experience is much, much longer. So that's about 20 years or more. So yeah, it was about 8 years ago when I had an idea for an app. I was getting into microtonality, got really interested in some of the theories and ways of learning about ways of constructing scales using just intonation. And so I wanted to make music like this. And I quickly realized that, I won't, this is kind of another talk, but yeah, there was a lot of issues I came up against. And so I decided to write an app, and that's what got me into learning JUCE. I discovered JUCE after trying a few other different frameworks, and an interesting thing happened during that time, which was I started to care a lot more about programming, about clean code, about good programming practices, and getting into open source contributions. I was making suggestions to fix things in JUCE to help in that period, mainly with the Android implementation. And so yeah, I really started to. It was like bringing the passion into programming through doing something that I was something I really wanted to exist. Bringing the passion into it really helped to up my programming game. So because it made me care about this stuff. Whereas before it was just a job. For many, many years, coding was just a job. And the rest of my life was in the studio making music and doing other stuff. And then another important part of my journey, while I was working on this app and kind of battling with JUCE, trying to get a JUCE app to feel good on a mobile device, through some of the problems that I solved while building that app, I decided to do a talk on it. And the actual reason I did that talk, so the talk I did was at the JUCE Summit in 2015. And the reason I submitted my talk was initially just to get a free ticket to get in. So I didn't have a lot of money at the time. And I thought, you know, I've got some stuff to talk about. I can talk about this stuff, you know, to do with how to get that I'd been working out how to get a native mobile app with JUCE UI within it. That was the challenge I was working on at the time. So I thought this might be useful to some other people. It took me about 15 or 20 minutes to write this proposal and send it. And then a couple of months later, I got an email from the JUCE team, and I was expecting it to say, thanks, but we've had so many other talk submissions, and actually what the email said is, we'd love you to come and present your talk at the JUCE Summit. And I was like, at that time, I was like, suddenly I was like, oh, I have to prepare a talk now. Okay. But that was, I put a lot of time into preparing that talk. And that was and giving the talk was a really pivotal moment for me and my career. So it was, I was super nervous. And yeah, there's, I was so nervous giving that talk. I was in a room full of people. It was being live streamed. And I kind of, because some of my talk was, kind of had a few like little negative things to say about the JUCE framework, in the context of using it for a mobile app. And I was kind of at the back of my head thinking, I really hope Jules doesn't walk in. And then about 2 minutes in, 2 or 3 minutes into doing the talk, Jules walks in and comes in, walks in right around the front and sits down right in the front row and crosses his arms and legs, and he's looking straight at me. And I was like, took some breaths and carried on. So yeah, that talk was really, as I said, really pivotal in catapulting my career in this area. And what directly resulted from that talk was meeting Dave Rowland, who introduced me to a previous client of his, where he'd built a mobile app using only JUCE, and they really wanted to make it more of a native look and feel app. And yeah, so he introduced me to his client, and she became my first freelance client as an audio software developer. So yeah, after that was, I kind of picked up a skill that I'd had previously. So I'd worked as a freelance web developer before. So this was kind of for me doing similar stuff, but in a new industry, and using JUCE and C++ instead of, I was a Ruby on Rails developer for a while before that. So yeah, I think what I want to highlight by this part of my story is taking a risk and putting yourself out there is so important. It doesn't matter what you're doing actually, but that it's just such an important thing to be able to do is, push through your fear and really just get yourself out there, get your ideas out there, speak in front of people. It will take you to places that you won't even imagine. So that first talk that I did in 2015, I still get people approaching me that have found that talk on YouTube because they're trying to solve similar problems. Even though that talk is now really outdated, I do stuff, the way I solve that problem is quite different to how I presented it then. So another thing I want to get into now is something that's been a really important part of my journey and links back to the first exercise that we did, is coaching and mentoring. So I first my first coach was a guy called Martin. And the reason I took him on was I'd got into a position which is maybe familiar for some of you that have been freelancing for a while. I think this was maybe my third client project. And this particular client, I knew he was running out of money. You know, there was some, you know, he told me that he didn't, you know, he was running out of budget. And I really wanted to get this project finished. So I just kept on working on it and trying to finish it. And what was actually happening was my hourly rate was shrinking and shrinking and shrinking, because I was trying to get this project finished, and I didn't really want to, you know, I knew he had limited budget. So I just thought I'll just finish it and then it'll be done and I can move on to the next thing. But as sometimes happens, especially when you're starting out, new little problems, you know, came up, and it just took it was just taking a really long time and causing problems at home. At the time, I was the sole breadwinner at home. My partner had a little kid, you know, I was causing stress at home. I was super stressed at this point, full of stress and anxiety. And I remember seeing this guy, he worked in the same co-working space as me. And I saw this guy at the other end of the room. He was speaking to a woman, and he was full of like joy, and he just felt that he had this joyful lightness and confidence about him. And I knew he did coaching and mentoring. And I looked at him and I was like, I need to speak to this guy. I need to go and see him. So I waited for him to finish having the conversation he was having, and I walked straight up to him and I said, Martin, I think you might be able to help me. So he said, okay, sit down, tell me what's going on. And I blurted everything out. Just, you know, all this stuff came out, and he was like, okay, slow down. Let's set up a session together. So we set up a session, and he got me to prepare some things. He gave me some questions, and he prepared some questions for me to answer in our session. And that was another pivotal moment for me. He got me to promise never to reduce my hourly rate, and taught me that almost every problem can be solved through communication, and most problems come about through communication problems. And so from that, I had the confidence to be transparent with my client and work that problem out. And, you know, things got a lot better after that point. So I'm going to fast forward a little bit in the story and talk about what led to starting a company. So one of the things that I was encouraged to do is take on other people. So rather than so I got to a point where I was getting a lot of interest in what I was doing, and I started having to say no. And I was encouraged to set things up so I'd be able to say yes more. So what that looked like was hiring, you know, finding other developers that I knew and bringing them on to help with projects. Yeah, and I mean, one mistake I made at the beginning for moral reasons was I didn't want to, like, I was bringing people onto a project, and I was charging my client what they were charging me. And, you know, I had this moral issue that I can't charge the client more for this person's time than they're charging me. But quickly, I realized this isn't working, because I'm spending time finding people, I'm spending time talking to them, I'm spending time, you know, working out problems with them and managing the project, and I'm not getting paid for that. You know, I'm not that extra time isn't being paid for. So that's another thing that I was taught, really, is like basic business, you know, which, you know, coming from my, you know, my thing has been, it's another thing that I've been getting over in the last few years is, you know, just yeah, realizing this, this is running a business. This is part of running a business. You have to have your margins, and you have to be making profit, right? So that's what led to me starting my company. I was bringing people on to projects, and at some point, I realized that I need to do this properly. I need to have a company. So almost 2 years ago now, I started my company. Actually, Node Audio. It's a bit complicated. So I had two companies, and now I've recently merged them into one. So I started Code Garden company, which initially was the purpose of it was B2B, providing consultancy and software development services. So yes, I started a company, and that was another pivotal moment where I was like, okay, now I feel like I'm doing things properly. I've got a company, so the contracts are with the company, whether it's client contracts or contracts with developers. So having this sort of separate entity that's not just me, yeah, felt things started to feel a lot more proper at that point. And I've been like, since then I've been, it's been a very up and down journey, and like I still feel like I'm pretty close to the bottom of the mountain that I'm trying to climb. And maybe that's an ongoing thing. Maybe people always feel like that. I don't know. But I still feel like there's a lot to learn. But I've learned a lot, especially in the last 2 years. Yeah, and so I think I'm going to switch back to some questions now. But these are questions I've been asking myself as well. So, excuse me. So the question is, what will your business look like? What do you want your business to be? So if maybe you're okay with just keeping audio programming as a hobby, or maybe you want to be employed in a really good company, which is definitely a great thing to do. Especially if it's a good company with good culture, you can learn so much from working in a good workplace with and good colleagues. But if what you want to do is turn your skills as an audio programmer into your own business, then you got to make a decision of what that business is going to look like. So are you going to serve clients? Is it going to be a B2B thing where you're serving clients? And so I'm just going to do a time check. You're serving clients and helping other people or companies to develop their own products. That's the main thing I've been doing. Or do you want to create something? Do you want to create a new plugin or an mobile app? Do you want to sell products to end users? And there is a third path that's not so commonly followed, but some people do quite well out of licensing code. So licensing code or creating useful libraries for companies to use in their own products. That can be a really good thing to do. So the thing about serving clients is, and this is something I'm working out at the moment, is I've realized, it's often custom work, and it can be quite time consuming to do that. And so if you can find a way to create useful code libraries, it becomes much easier it's much more scalable, is to use the business lingo. So yeah, and another thing I've really, it's become really clear to me since I've been on this, been walking this path, is selling products to end users is very different to working for clients. Because when you're selling a product, you have to convince a lot of people about your product, right? So, you might think it's really cool, you might believe in your product, but you've got to somehow convey that energy and passion that you have for what you're creating. You need to convey that to the rest of the world and hook them into what you're doing. And what I've found is that it's almost diametrically opposed to programming. So as I think a lot of programmers struggle with this. I think it's something I see a lot, is people come up with cool ideas. They maybe get a really nice prototype. They maybe even get something, really solid. But when it comes to actually selling it and marketing it, that can be, that's a hard thing to do when you're not used to that, when it's not a natural thing. I think for some people it comes more, more naturally than others. But in my opinion, it's, like I said, I feel like it's diametrically opposed to the kind of mindset that you're in when you're programming. You're like deep in your, I sit like deep in my cave. I'm working out problems. I'm, solving lots of little problems and building something, compared to the marketing, which is kind of for me like zooming out and looking at what am I doing? Why am I doing it? Why is this useful to other people? And how do I convey that to the world? And that often means it's like putting yourself out there in some way, whether it's creating videos, or, putting yourself out in some way to give the message about your product. So I'm just checking if I've covered the things I wanted to cover. Can I? Okay. Yeah. So, yeah. Okay. Sorry, I just got a bit stuck there with the next thing to talk about. So, yeah, another thing that I've, that's changed in me in the last couple of years is how I see marketing. So I used to think of marketing as something inherently evil, that it's basically for, the purpose of marketing is to sell people stuff that they don't need. And actually, how I'm seeing marketing now, it can definitely be that, but marketing as a whole, it's just like I just said, putting yourself out there. And it doesn't have to be evil. In fact, it can be the opposite. It's like, it can be really inspiring. And it's really, for me, like, it's about, it's a form of, in the positive sense, of shining your light out into the world, like affecting the world in a positive way. So going back to the early questions, like, why are you doing this? What do you want to, is there something really cool you want to create, or some change you want to affect in this industry? So the marketing is really you shining that out, and, really, being a force for positive change in the way that you want to be doing it. So I think that's what I wanted to say. And I hope I've inspired some people who are at various stages along this journey. And I mean, I don't know if we've got some more time left. I could go into some detail about some of the mistakes I've made in recent times. That might be useful.
Yeah, please feel free
Yeah.
to go. Please feel free to share with us.
Sure, yeah, I will. I'll expand on some things. Thank you. So just want to relay some things, that I've learned in more recent times. Like, so I've I had some coaching earlier, from about a year ago, and this is a different coach, and this person was encouraging me to scale my business. And so I took on more developers, and she encouraged me. She encouraged me to take on developers, but what I didn't realize at the time, and it's really clear to me now, is when you're growing your business, you need to have systems in place and extra people in place to help that happen. I'm sure you're familiar with this kind of stuff, Josh. And what ended up happening is I brought on more developers so I could take on more projects. And what ended up happening is I was basically project managing full time. Had very little time to actually do much programming. And I was constantly context switching between different projects. And it was very, very tiring. And because of this, I also, through this, I wasn't able to properly attend to each client project as I had been in the past. And I let a couple of people down. Things took a lot longer than we anticipated. And I'm relaying this. And another mistake I made was taking on, fixed price projects and not spending enough time on the scope, not spending enough time doing an estimate. And got bitten by that. And I'm just sort of climbing out the other side of that now. So I just, these are little things I've picked up on the way, these are really important things to consider to save yourself pain. And I think the main thing is, just breathe and, every opportunity that comes your way, just really consider it and think, is this something I really want to do? Is this a client I want to work with? And really make sure you're valuing yourself. So yeah, that's an extra thing I wanted to share. So I think I'm going to conclude it there.
Yeah, it sounds like in that lesson that that programming is very important to you, and it's very important to how you're feeling to be able to continue to do that no matter what role you are in the company. Is that correct?
That's really true. That's a really interesting point, because a lot of what I've been learning about entrepreneurship and running a company lately is a lot of the wisdom is you need to stop doing the day-to-day stuff, come out of being the implementer to being the leader. Right. And I guess that's a path a lot of people follow. But yeah, personally, to me, I love programming. I don't want to stop programming, but I think that the challenge is to set things up so that I'm leading and also doing some of the programming that I enjoy in what I do.
Mm-hmm. And so how do you do that? How do you do that in your particular line of work? Is it by taking less projects on at a time? Is it that you have somebody else who takes on that more strategic role? What do you do to do that?
So this is actually a process that's happening right now. So I'm in the process of shifting things. So I don't have a clear answer to that question right now, but it's something. These are changes that I'm making at the moment. Like bringing on, bringing on a project manager who can take over a lot of the communication. I already have some developers I work with who have strengths in different areas that I don't have. Yeah. So I think, yeah, the idea is, to be able to be in the driver's seat of the business, as well as doing some of the programming that I enjoy. But really, that's I think that's the thing. Running a business is ultimately, I think, about being a leader, being an inspiring leader to others, and embedding your values inside your business.
Mm-hmm. And what would you say those values are for you?
It's a good question. One of the values. This is good because it's something, these are things I want to get more concrete. One of the values I remember is to allow people flexibility, so that people are able to focus on other aspects of their lives, because that's a challenge that I had for a long time when I was making music and working. It was a constant battle of trying to make more time for music while satisfying the company I was working for. And then I thought freelancing was going to be the answer, but then you have to manage your time, and that can be sometimes even more challenging, managing your own time between serving your clients and bringing enough money in and doing other stuff that you enjoy doing and that's important to you.
Very interesting.
And another thing, in terms of values, it's like code review is really important. So, I've personally grown as a developer massively through having my code reviewed by people much more experienced and able than myself. So that's already an important part of the culture that I'm trying to build. Is there are times when project pressures, you have to sort of ease off the code review, but I think it's so important to have code reviewed and enable people to grow by seeing, having things questioned in a constructive way.
Yeah. So quality code, flexibility, and what was the third one? Growth, right?
Yeah, personal growth.
Personal growth. Got it. Okay. So there was a question in the chat. I'm not sure if you saw it, Adam.
No, I can't see the chat.
Okay. So there's a
Maybe
question from Matthew Rice who asks, how do you determine what is a reasonable number of projects that you and a team of people can manage at the same time?
Oh, it's a good question. I'm still working that one out as well. Thanks, Matthew. How do you determine what number? Honestly, I think knowing myself, like I can comfortably, the ideal is that if I'm personally working on a project, like, 2 projects at a time is a good number.
Mm-hmm.
When it gets beyond that, I start to, what I'm able to give each project starts to deteriorate. Having said that, I often have, 4 or 5 projects running concurrently, but then there's varying degrees of, what's the word? There's varying degrees of my input that's required in these projects. So some projects, I'm kind of deep in and following them and working on them. Other projects I've got, great developers working on them and I'm just checking in with them. So it also depends on the needs of each project.
Yeah. Okay. There's a question from Backpack Vacuum that says, it sounds like you're on the tail end of a journey that I'm just now beginning. The issue I'm currently facing is confidence in my abilities and imposter syndrome. Can you speak to those issues?
Yes, imposter syndrome. That's very familiar to me, and I'm sure a lot of other people. What I've heard is imposter syndrome never goes away. So as long as you're growing, you're going to get some form of imposter syndrome. Some people don't. There's a guy called Marius who I forget his surname, but he was on the ADC panel in November, and he's the author. Or he goes under the name of Crushed Pixel, and he's the author of a plugin called the original author of Crispy Tuna, which then got bought by Plugin Alliance, and he's like a particular kind of person. He's got a lot of confidence. He even calls himself overconfident, and I see him. He's in a way like a perfect entrepreneur because he's full of drive. He's full of energy. He's full of confidence, and so he can convince people around him, and he's very focused. He had this idea. He worked out a plan of how to execute the idea, and he did it. So I think, but I think for most people, there's going to be some level of fear and imposter syndrome. And that's something that's not going to go away. Like basically, if there's some level of fear, then that means you're actually doing good, right? That means you're growing.
Journeying into the unknown.
Exactly. You're journeying into the unknown. If you're comfortable, that often can mean you might be that might mean that you're stagnant. You're in a comfortable, happy place, and that can be okay. But if you want to grow, then there's always going to be some unknown, and that is going to trigger some fear because we are human. Yeah, that's just an unavoidable fact.
Yeah, it sounds like it's all coming back to determining what type of leader that you want to be. So there's a more visionary leader, and what you're describing, which seems to be more like a technical leader, a leader that where the values are good code, good technical, a good technical foundation, and things like that. Am I right in saying that?
Kind of, yeah. So that's the culture I would like to build within the sort of, I guess, the technical side of my company. But there's a whole other side of my company, which is, I want to, in terms of my vision of what I want to put out into the world, right? So that side of it is, I want to put out, my thing is microtonality, and I've got interest in both breaking the current grid of frequency and also of rhythm. That's something else I'm interested in. So yeah, in terms of wider values of, in terms of the products I'm putting out, it's really about, challenging the music industry and providing new tools that can help people break through these existing creative constraints.
Knowing yourself and knowing your own strengths and being able to amplify those.
Yes.
Is that right?
Yeah.
That sounds great. Yeah, seems like a lot of positive feedback from the chat, and people have been sharing their insights. Thank you very much for sharing your experience, Adam. That's very brave, and I appreciate that.
Thank you, Josh.
All right, great. We'll give a couple more. We'll give about a minute more for any more questions that you have for Adam to flow through. In the meantime, I'll just let you know about the audio programmer community on Discord. So it's very common that all of us in the audio programming world have questions and need help from other individuals. And what we've done is we've set up a Discord where people can ask each other these questions. And we have a wide range of developers, from experienced developers working in very large companies to indie developers working in very small companies to people still trying to get into the audio development field. You can join us. Link is in the video description below, and the link is theaudioprogrammer.com/Discord. Thanks once again, Adam, very much for sharing your insights. Looks like that's it for the questions. So yes, thank you very much.
Thanks for the opportunity. Thanks, Josh.
Great. Okay, so with that, we're going to go ahead and move into our next talk it's great to have Rachel Locke back here. Many people have been asking me when the next episode of DSP Corner is going to be. For people who don't know what DSP Corner is, it's a place where where Rachel has been giving her insights into the industry and creating some lessons for people that are looking to get more into the digital signal processing side of the industry without all of breaking down some of the technical jargon into easy to understand language. And Rachel is back to give her next episode, which is going to be on the Fourier transform, and she's going to be using MATLAB for this. We're looking forward to having her back again. Thank you, Rachel, and take it away from here.
Hey, thank you, Josh. I always feel like you're saying that people have been asking you to hype me up because no one ever asked me personally, but maybe they feel more comfortable to approach you.
Hey, I don't know.
But yeah, thank you for all the positive feedback that I do get in the comments and the posts that I make about DSP Corner. It really means a lot to me that people are getting value from it. And that's why I continue to make the videos. Okay, let me try and share the screen. I had a moment ago, MATLAB online was freeloading, and I was thinking, this isn't a good start because I had some issues with MATLAB online when I did my workshop at the Audio Developer Conference. I'm hoping today it's going to behave itself a bit more. Okay, let me just try and get to the screen share on Zoom. Okay, let's go for this one. Can we see the slides?
Okay. Yes.
Cool. I'm using two screens, so that's why I'm like losing the mouse. I've got, I'm looking in different directions, but bear with me. Okay, we've gone full screen.
Yep, you're all good.
Okay, cool. So yeah, thanks, Adam, for prompting us with those questions as well, because it really got me thinking about things, and it was a really useful exercise. And it got me thinking about why I started this series and why I continue to do it. And when I was developing this episode of DSP Corner, I considered leaving out the heavy mathematics of the DFT for fear of putting people off. But I realized that that is counterintuitive to the mission of this series. So this series is a sort of peace offering to myself and to others that have felt overwhelmed, disheartened, and felt that they just weren't cut out or didn't have the right education to learn digital signal processing, which was myself at many points in my master's degree. So I would be doing you a disservice if I didn't try and break down the essential mathematics that you'll need to become comfortable with if your goal is to work in a role where you'll need at least an understanding of audio DSP concepts. And yeah, I hope that people find this useful. And like I always say, I'm right at the beginning of my DSP journey. I'm not an expert, but I break things down in a way that I would have wanted when I was starting out. So let's get into learning about Fourier analysis in MATLAB. Okay, so up first, we have the formula for the discrete Fourier transform. And the best way that I've found for building an understanding of these really quite gnarly DSP formulas is to break them down into digestible pieces and focus on first understanding those pieces of this puzzle before addressing how they relate to each other. So like I said, here I've got the formula for the discrete Fourier transform. You'll know it's discrete because we're dealing with samples n and frequency bins k. And we've got square brackets. And for a continuous Fourier transform, you'll be dealing with integrals and integrating and integrating areas under a function. But this channel focuses on the digital side of signal processing, luckily, because I'm hopeless at integration. Okay, just switching between the screens. So what I've tried to do is break this down into 4 pieces, and we're going to try and understand the individual pieces before looking at how they relate to each other as a whole formula. So on the left side of the equation, we have this uppercase X of K, and this is the output of the discrete Fourier transform. And this is a complex output, meaning that we will have a real and an imaginary part. And rather than a sample index, K tells us the frequency bin number. So rather than samples in the output of our DFT, we'll have frequency bins. And the number of frequency bins will correspond with the number of samples in our input signal. The next segment, I think, is one of the 2 pieces of the puzzle that people find quite daunting at first, because it looks like a very unfamiliar mathematical symbol if you haven't seen it before. But this symbol in the middle there, like a sideways sort of M, is called sigma, so Greek letter sigma. And sigma basically means to sum. So it represents the summing of values over a given range. In this case, lowercase n is the sample number. Uppercase N is the total number of samples in our input signal, X of n, and the range n is defined from 0 to n minus 1. And in the example we're using, the signal is going to have 16 samples. So we're going to be summing over a range of n between 0 and 15, because it'll be 16 minus 1. And what sigma will have, what the summation will have, is it will have something to its right here. And basically what that will mean is we're summing whatever is here to the right over a range of whatever is defined on the bottom, that will be the beginning of your range, until whatever is defined on the top, that will be the end of your range. And I've just made a small example in MATLAB to show how summation works. So I'm just going to jump over there and see if we can get that running. Cool. So MATLAB has this, I think it's called a live script functionality, where you can, it's quite cool because you can put text and your code. So you can put in some examples of equations that you're trying to implement in code, or just anything that you're trying to figure out. You can also put some text about what it means. So again, I've put sigma means to sum. We sum whatever is to the right of sigma, in this case, the values of our signal X of n. The range of n, which we're required to sum over, is specified at the bottom and the top of sigma, where the bottom is the start of the range and the top is the end of the range. So in the example I've given here, you can see that we're going to be summing over the range 1 until n. And again, n is the length of our signal x that I've created here. And we've stored a variable for n as the length of x. And it may be a little confusing in terms of not starting at 0 up here, like we do in the actual DFT formula. But that is because MATLAB indexes from 1. So we've decided to go with 1 because the first index of our array here will be the index 1 instead of index 0, which it is in other programming language. So yeah, just a little bit confusing and takes time to get used to in MATLAB. And like I said, we're summing over a range. So a good way to implement something when a range is involved is to use a loop. So I've got a for loop here, and it's starting from n equals 1, and it's looping 5 times until n equals 5. And inside the for loop, we're going to be summing the elements of this signal x. And then at the end, we're going to print the sum. So if I run that, you can see that x has these values. The length is 5, and the sum is 66. So that's just sort of introduction to how summation works. We might have implemented it before, not known. I think when you see it in a formula, it can look much more daunting than just summing over a range. So I hope that example helped you to understand summation if you hadn't seen it before. Just going to jump back to the slides for a moment. Hopefully we're still on the same. Uh-oh. Let's go forward a bit. Cool. Yeah, so we were here. So yeah, we've just looked at this portion. So now we know we've got a summation, which is going to be from 0 until the length of our input signal minus 1. So it's going to have the same number of sums as the length of our input signal. The next segment is the input signal itself. We've seen this before when we looked at introduction to mathematical notation and signal processing. We can see that the input signal has an independent variable n, which is samples, and it's got the square brackets there to show you that it's a discrete input signal. Not too much more to say about our input signal. It's going to be, in our case, when we do the example, it's going to be a pure sinusoid input signal with 16 points. And I think maybe best to quickly show you that now before we move on to the most daunting part of this formula, which is called a complex exponential. And I think that's the one that trips people up the most. Definitely did for me anyway. Okay, slide comparison. That sounds right. Just going to close these down. Okay, so can everyone see the code all right? How's it looking, Josh?
Looks great.
Yeah? Okay, cool. As long as it's readable, that's great. And okay, I've tried to comment everything quite well here. So when the video goes out, it will be easy to relate back to and see what I meant in each line of code. And I will release the slides and the code as a companion for the talk as well, if anyone wants to have a go. Right, so first things first, I've given a sample rate, which is our samples per second that we're going to take. I've taken the period, which is the reciprocal of our sample rate. I always denote this as seconds per sample. because it's how often we need a new sample based on what our sample rate is. I've given a duration, so I want a signal of 1 second, meaning that we'll have 16 samples because there are 16 samples per second. I've given a frequency of 2, which is our cycles per second. So we're going to see 2 cycles in that second that we're going to plot, and that 2 cycles is going to be captured by 16 samples. I've created this time axis, which is what we're going to plot the values of our signal against. And then finally, I've created a cosine with the frequency 2, and we've put that time axis in there. Okay, I'm just going to run this. Maybe I'll comment out the FFT for now. Just comment out. Let's see how long it takes. That was surprisingly fast. Okay. So you can see that we have the general shape of a cosine wave here, and that is captured with these 16 lollipop samples that you can see on the plot. And this is a plot of amplitude over time, as we generally see in the time domain. And if I open up the command window, I plotted the values of our signal by just putting this line that says X. If you don't put a semicolon at the end of a line in MATLAB, then it will print that value or those values to your command window. So I've just done that to show you that our signal is just a range of values. And it has 16 altogether. Okay, I'm going to jump back to, actually, I'll just show you one more thing in the workspace. When I was talking about the output of the DFT having K frequency bins and also having complex values, you can see, I'll just close that down, that you have the FFT here. Okay, so this line, I'm actually calculating the DFT of our input signal X. And we're not going to do anything with it yet. I'm just wanting to show that we've got our input signal lowercase x, and that is 1 times 16, so 16 samples long. And you can see that uppercase X, which is the output of our DFT, also has 16 elements, let's say, and that they are complex. So that will be our 16K frequency bins, and they'll be complex numbers, meaning that they have a real part and an imaginary part. I don't know if I've actually covered this in any of the DSP corner or whether it was in the workshop at ADC, but the real part of the output of the DFT is the magnitude. So how much the contribution of that frequency is at that bin. And the imaginary part is the phase information for that frequency. Hopefully I mentioned that before. We can look at that in more depth if people would like to, but hopefully it will make a bit more sense when we look at the complex exponential just now. So I'm going to jump back over to the slides. Hope for the best that they caught up. Okay, I think we're back to where we were. I'll just point out as well that this complex exponential that we're about to look at, just get the highlight around it. this is something that I've written slightly in shorthand with the omega k. And down here, I've given what you would plug in if you wanted to write the longhand of this. So omega k is 2 pi over n, with capital N being the length of our signal, of our input signal. And quite often, if you're looking in textbooks for DSP or looking at DSP code, you'll have this, this practice of using lowercase letters for the time domain and uppercase letters for the frequency domain. And that's why we've got the lowercase x for our time domain input signal and the uppercase x for our frequency domain output. Cool. And because the complex exponential is quite complex, even that's not the exact meaning, I've dedicated a whole new slide to it. Okay. The discrete Fourier transform, how? So we're about to find out that the DFT is simply a point-by-point correlation of a discrete signal x of n, which is our input signal, with a collection of sinusoidal waves oscillating at frequency omega k. So omega is used to denote angular frequency, which we've looked at before, I think, when we were talking about sines and circles. So if you want to know more about converting between angular frequency and in radians and frequency in hertz, I think you can look back at the circles and sines video or the introduction to mathematical notation video on the channel. Okay, so what does it mean, point-by-point correlation of this signal with these signals? So x of n, like we said, is our input signal. And the reason we're doing a Fourier transform is we want to know about the frequency content of our input signal. And the way that we're going to find that out is by comparing it to base sinusoidal waves at different frequencies and seeing what the measure of similarity is between our input signal and some test signals, let's say. And if there is a strong positive correlation between them, then that will suggest that that frequency is present in some amount in our input signal. So this complex exponential that we've got on the side here, it has an exponent, which includes the complex number, or the imaginary number j, sorry, can also be denoted as I. It's got a frequency component and it's got a sample index n. Okay, so it's known as a complex exponential, and the multiplication of the input signal x of n with this complex exponential is what makes the output of the DFT complex. It looks daunting, but we can rewrite it in a more intuitive way. So there's someone called Euler who developed a formula, and it allows us to rewrite complex exponentials as its cosine and sinusoid components. So the one you'll see most often is this top one. E to the j x can be rewritten as cosine of x plus j sine of x. But you can see in our exponent, we've got a minus sign. So if we put the minus sign in there, all it does is it changes the sign from positive to negative. So we can rewrite our complex exponential as cosine of omega k n minus J sine of omega kn. And if you saw the episode on complex numbers, then you recognize that this is a complex number because it has a real part on the left and it has an imaginary part multiplied by the imaginary number J on the right here. And if I just jump back to the previous slide a second, whenever you see something next to each other in a formula like this, it means that they're being multiplied together. So I just spoke about how to find the frequencies present in our signal. We're going to do a correlation of our input signal with a collection of cosines, and it's actually going to be inverted signs because of the minus sign, to see what frequencies are causing a strong positive correlation between our input signal and the test signals. So this means a multiplication. So if we look at the formula as a whole, we're saying that for each frequency bin of our output, of our complex output, we're going to be summing over a correlation of our input signal with both a cosine element and an inverted sine element to see what the overall score is. I hope that makes some sort of sense. We're going to do a demonstration in MATLAB and look at some animations that will hopefully make it a bit more clear. Okay, so the number of test signals that we're going to be multiplying our input signal against are going to be determined by the length of our input signal. And like it says here, number of base signals that are correlated with the input signal length. Here you can see a cosine component and an inverted sine component are generated for each frequency from 0 Hertz to 15 Hertz. And this correlates with our sigma summation that we saw before, where we had n equals 0 at the bottom and capital N, which is our signal length 16, minus 1 at the top. So a range from 0 Hertz to 15 Hertz. And I put the complex number up here, which is the cosine and the inverted sine component. So like I said, the reason that this sign is inverted comes from the minus sign out in front of our imaginary element here. And basically what's getting plugged in each time is this n. So it's going from 0 to 15. And as you can see, each time the GIF changes, the signal is going up 1 Hertz in frequency. Okay. This slide, there's a lot going on, so don't panic. We'll go through it step by step. I wanted to basically show what is the correlation process, like how does the DFT actually work? How does it determine what frequencies are present in our input signal? And we start off with the correlation. The lollipop stem signal you can see in orange here, or maybe red, is our input signal, x of n, which has 16 samples. The continuous or continuous looking wave, because nothing can be continuous in a computer, we can just give the impression of continuity by giving a very fine resolution. This is our cosine test signal. On the other side, we have, again, our input signal and the inverted sine test signal. And I've used the 2 Hertz one as an example because, as we know, that's the frequency that we're trying to find present in our we're trying to verify that that is our input signal. It's a 2 Hertz sine wave or cosine wave. So that's what we're trying to verify, that we're getting the right result for that one. And as you can see here, this is matching up very nicely. So that's what we would expect. And for the inverted sine, we can see that they have some points where they match. And we'll talk about why that is and why it cancels out. So the first thing that happens in the correlation is there's a point-by-point multiplication of the test signal with the input signal. And this causes a score, or it creates a new signal, let's say, of these two signals multiplied together. And this one below is that new signal. It's, if you can see, it's both signals are 1 at this point. 1 times 1 is 1, and about 0.7 here, times 0.7, which is down here, around 0.5, and so on and so forth. So this is our cosine correlation for 2 Hertz test signal. The next step is to sum all of these values together to give us an overall score of what how present this particular frequency is in our input signal. So you can see that if you sum all of these together, you get this quite nice high score of 8 at the frequency 2, which is really reassuring because that's what we're expecting, a high score for frequency of 2. So we verified that our input signal and our test signal have really high similarity there. For our inverted sine, we can see, like I said, that there is some points that the test signal crosses through, but also that there's lots of points where it doesn't. And you can see when you create the signal of the correlation that it does have some points. But you can see that when you add these points together, they're going to cancel out because they're equal parts positive and equal parts negative. So when we do add them together, we get a result of 0, which is what we're expecting, 0 for all frequencies, because our input signal is a cosine. So we wouldn't expect there to be a sinusoid or a sine part in there. And then to get the total of the contribution of that signal, which we call the magnitude, we have to apply Pythagoras. And if you saw, I know I keep relating back to other DSP corners, but it's meant to be a sort of a continuation on one to another. So sometimes I won't go into something in so much detail because it's been covered before. But essentially, when I did the episode on complex numbers, I was saying that to get the magnitude of the signal, which relates to amplitude, we need to find the length of the hypotenuse of the Cartesian form complex number. And that was done by just rejigging Pythagoras formula to get the square root of a squared plus b squared. And in this case, a is our number over here, 8. B is 0 for this particular score, 2. So ultimately, for the 2 Hertz test signal, we get this overall magnitude of 8. And I'll just show you the code, which I wrote to generate these blocks. I'm on a sort of trial license at the moment of MATLAB. So if anyone here works for MATLAB and you fancy sponsoring DSP Corner, I'd be very grateful. So I think I've got about 2 hours left on the trial. But thank you very much for sponsoring my talk at ADC. Very much appreciated.
I'm sure we could convince Gabriel to do a comp license for this. He would be very happy with this.
Because otherwise I'm going to have to keep creating email addresses, Gabriel. It's just,
Oh,
just
no.
putting it out there. It's going to be trial after trial. Yeah. I mean, hopefully I'll be earning enough at some point, buy my own MATLAB license, but I'm not sure we're quite there yet. Anyway, back to the talk. Where are we looking? So this one. I know there's quite a lot going on here, but when I put this code out, I'm gonna write a long README that will explain everything and why I've gone about it the way I have, because I found it very difficult to write an example of who'd have thought it, to write the DFT would be difficult. Obviously it's not as complicated as the actual FFT implementation in MATLAB, but it's just breaking down the steps of the correlation and the summation and everything that we've spoken about so far. So you can see that I've got, again, the same sampling rate, the same frequency of the signal that we spoke about in the other script. And what I've done is I've got a loop down here where I'm basically implementing exactly what we said on the formula, 0 to n-1 for n, lowercase n. And first thing we do is create these base sinusoids. So these are the sinusoids that we're going to be correlating with our input signal. And we saw them in the GIF that I made, where they're going up in frequency 1 Hertz at a time. So we've got the real part, which is the cosine, like we expressed before. And it has this variable n in here. And that n is changing on each iteration. So it starts at 0, and it goes all the way to n-1, which in our case is 15. And on each iteration, a different cosine and a different inverted sine are going to be created, corresponding to the frequency that n is at that time. And then I plot them all. To know about, might comment out this bit because it's about, well, it'll be 16 plots. But basically what I've gone for is plotting. Actually, I'm going to do it because I think it's a good way to visualize it. Let's see if it works. Oh, that's promising. Not seeing any plots yet though. Here we go. Something's happening. I'm like worried to press anything in case it freezes. Just giving it a second. Can we move to the side? Brilliant. Okay, so there's 16 plots here corresponding to the frequencies I spoke about. This is how I created that GIF, more or less, with the different frequency test signals that we're using. This one is for 0 frequency. So as you can see, the continuous line has no oscillation whatsoever in this case. This one's at 1 because cosines always start at 1 at 0.0. And this one's at 0 because sinusoids or inverted sinusoids or sine waves. I keep saying sinusoids, but sinusoids can mean both cosines and sines. But yeah, it's easy to slip up with the terminology. So yeah, that's 0. And you'll see a trend here as we go through. That's 1 Hertz. I've labeled them here. And you can see for the most part, there's not strong positive correlation here. They're not really hitting any points, or if they are, it's points that will cancel out once we do those next steps of the DFT formula until we get to 2 Hertz, which is the one that we saw. And we do have that strong positive correlation for the cosine part. And yeah, it just goes on like that until, all the way until 16, 15. Okay, I see what I've done. I plotted the correlation result over the last one, so these ones only got to 14. But yeah, there would usually be a 15 Hertz one there. Okay, and this is the correlation result. And we can see that we have that value of 8 that we saw when we did the calculation for 2 Hertz. We can also see something quite interesting, that we have another value of 8 for 14 Hertz. And you might be thinking, how has this happened? Because our input signal was a single frequency sinusoid. So how so that it has 2 frequency components? We never added 14 Hertz, so why is it there? Let's have a look in our next slide, why that might have happened. Okay. Well, this slide is hectic. Okay, so I've got the plot here that we were just looking at, and I've highlighted the positive score for 2 Hertz, which is what we're expecting. And I've also highlighted the positive score for 14 Hertz, which is not quite what we were expecting because we never added this frequency to our signal. So why is it there? And I've never done a video particularly focusing on sampling theorem, but I think we must have touched on it at some point. But if you know anything about sampling theorem, you'll know that half of the sampling rate is called the Nyquist frequency. And because our sampling rate is 16, our Nyquist frequency is 8 Hertz. And the sampling theorem states that you should have a sampling rate high enough so that none of the frequency components in the signal you're sampling are higher than this Nyquist rate. So they should all fall below 8 Hertz for the signal to be reproduced effectively, if you're thinking about analog to digital conversion and then conversion back from digital to analog. So we have our Nyquist frequency denoted here by the dashed line. And a phenomenon that we see is that a frequency that is present in our signal will be mirrored over the Nyquist frequency at the same distance as it was from the Nyquist frequency on the side, the left-hand side of the plot, let's say. So generally, all we're really interested in is this left-hand side of the plot, anything left of this dashed line, because this will not be audible. However, if we start having frequencies that are over the Nyquist rate in our signal, and we don't use a sampling rate high enough to account for those frequencies, then what we'll get, say we had 1 of 9, I should have really drawn this onto the graph, but just imagine there's a lollipop here. This will reflect back over the Nyquist frequency to create an audible new frequency that wasn't there in the first place in our signal. And that means we're actually adding harmonics, which isn't necessarily a good thing, but it's the way that a lot of distortions work, as you might know. And yeah, that's called aliasing. If you want me to do a video on aliasing, then let me know. But I think there are really good videos out there on aliasing, so I'm a bit, and sampling theorem, so I'm a bit hesitant to do that. But if you think it would work, let me know. And yeah, I hope that explains that plot. But on the right-hand side here, I basically included the reason that this is happening. You can see that, okay, on the 2 Hertz, as we expected, all the points of the blue wave, the test signal, are passing through the points of the input signal. But we also have this situation with 14 Hertz, whereby the test signal just happens to pass through all those points. And that is what causes us to have this result of thinking that this 14 Hertz is present in our signal. And I think, I'm not sure whether to do an actual FFT to verify that it's, yeah, let's do that really quickly. Just verify that, yeah, the FFT will produce the same result as what we've just looked at in my unusual implementation. So let's just verify that that works. Okay. So this is the same code as we saw in my implementation. Just I'll run it again so you can see the sinusoid. This is our cosine input signal sampled at 16 Hertz with a frequency of 2 Hertz. So when we take the FFT, I'll mention as well that there might be a bit of confusion between me using DFT and FFT. So the fast Fourier transform is an optimized version, optimized algorithm of the discrete Fourier transform. And it's optimized for signal lengths that are powers of 2. So maybe next time we could talk about windowing and zero padding. And these are ways that we achieve lengths of powers of 2 of our input signals, if they aren't already, in order to make use of that optimization, and also to increase our frequency resolution, which means that we'll be able to see frequencies, differentiate between different frequencies in our FFT output more easily, and not have them sort of smear into each other and not be very easily individually distinguishable. So yeah, MATLAB has the implementation of the FFT. So that's why, if there's any confusion between the two. Then I've also got this X mag and this X phase, and this is me grabbing the real part of the FFT output. And this is me grabbing the imaginary part of the FFT output. And like I said, the real part is the magnitude of the frequency present, and the imaginary part is the phase information of the frequency. So let me just uncomment this, and we'll have a look quickly before I finish. Okay, I actually might plot it instead of stem. 1 moment. Stem is just used to get those like lollipop style plots that we've seen throughout, but plot just uses straight lines, continuous lines. What's happened? Uh-oh. Invalid color. Oh, I see. That's what's done. Apologies. Okay, we're going to run. Okay. So first thoughts are, why is this at 3? We expected it to be at 2. And that's because these are our frequency bins. So our axis isn't yet in hertz. And I'm just going to show you quickly how to convert from frequency bins to frequency in hertz, so you can see accurately what frequencies are present in your signal. As we expected, we have this other peak, which will be the frequency mirrored over the Nyquist frequency. One thing that we can do, I said about phase information, say that we added a phase shift onto this cosine that we've got here, and the phase shift will be at the end here in the cosine calculation. Let's say 2.4. A cool thing that we can do is, if I run this again, we can verify that our phase information in our FFT output is correct, because I've calculated this X phase, which is our phase information, and we know that our peak is at frequency bin 3. So what we can do is grab the third element of our X phase. I could actually just do it in the command window. And we can see that that's 2.4. So that's the phase information that we're expecting. That's a good way that you can validate that. And I'll just show, if I can remember off the top of my head, how to convert from bins to frequency in hertz. I think it is. So we want an axis of 0 to n-1, but we want to multiply it by our sampling frequency divided by the number of signals in our input signal. I think that's right. Let's see. Anyone that knows, please correct me if it's wrong. See if that works. Do I have an n? Nope. This is like turning into one of Josh's live coding sessions. Me just talking to myself. Oh no, not normalized. Length of X. Okay. Let's see if this works. If not, I'll fix the code and get back to you. Oh, moment of truth. Yay! Now you can see that the frequencies are in the right place. So, and it's the same as like my implementation. Everything worked out.
Fantastic.
I think I'm going to stop there because I was trying to pack too much into the talk. Yeah, I think I went on a lot longer than I planned. I hope that was useful, and thanks for listening as always.
Thank you very much, Rachel. I know that was very helpful for people online, and yeah, like we were saying, Rachel is back nearly every month, providing new lessons and demos on DSP fundamentals, and this is one of the essential ones. So thank you very much, Rachel, for doing this for us.
Yeah, thank you for having me. And I just wanted to quickly say that I saw in the chat, I think someone maybe called Wave, let me check. Wave Sequencer was saying that they would get major imposter syndrome if they were to give a talk. But I want them to know that I am a bag of nerves whenever I give a talk, and I just keep doing it, coming back time after time, hoping that one day I'll feel less nervous. And yeah, I just hope that that inspires you to give a talk if you have an idea for one.
Absolutely.
Well, I'm going to stop sharing. Thanks very much.
Yes, thank you very much, Rachel. All right. And with that, we'll go ahead and jump into our final talk with Ali Koretsky. Ali is the head of AI and machine learning and audio science innovation at Splice. And he's here to talk about the current landscape of AI and audio. How's it going, Ali?
Hi, Joshua. Going well. Thanks for having me.
Yes.
Hi,
thank you very
everyone out
much.
there.
Great. I will go ahead and turn
Alright.
over the mic to you. Thank you very much. And
Sounds great. And I'm going to start sharing my screen. Okay, screen is shared. All right. Screen-wise, all good?
all good.
All right. Okay. Hi, everyone. My name is Alejandro Ale Koretsky. I'm the head of AI and audio science at Splice. In the next 45 minutes, I might run a little long actually, but hopefully 45 minutes only. I'm going to do a little bit of a blend of the journey, my journey, and some of the work that me and my team have been doing for the past few years. Before Splice, at Splice, and then some intuitions in general around machine learning and specifically applied to audio and in the context of music. How do we keep humans at the center? So it's going to be a blend of a little bit of everything with some cool demos. So hopefully you will all enjoy this. So a little bit about me. I already said I'm head of AI at Splice. My background is in electrical engineering and telecommunications engineering. And for the past almost 20 years, I've been working at times at the union, at times at the intersection of applied research, audio DSP, machine learning, also image processing, but also product management and UX. I used to be a designer a million years ago, so I care a lot about product experience. I've also been an entrepreneur myself as a founder, advisor, mentor, currently mentoring teams at Techstars. And also a connection with music. That's something very, very special for me. And given that I'm giving this talk from my home country of Argentina, as cliche as it sounds, I love football stakes in Argentina as well now, especially that we won the World Cup. So that's pretty much me. And I usually start this with a very holistic view of machine learning in general for those that are still trying to grasp what this is all about. And I like to define it as a new paradigm of automation. If we think about, and I like to use this kind of like an analogy with the box. And when we think about what the revolution of software has been for the past, almost 100 years. And we can describe it as a revolution on automation. And what we have been doing for a long time is using our domain and our understanding about the structure, the attributes, and what we can call the distribution of our input data. And based on what we want to happen at the output of the system, we derive and implement a series of operations or rules to try to automate certain process and in a way automate decision making. That's pretty much how, very holistically we can define what the great era of software gave us, and an incredible era of automation. And these rules of operations, at the end of the day, what they do is they describe a model, right? And in this case, I'm using like a clear box because this model has been built based on our knowledge and understanding, so we have full visibility and control over what's happening inside this box, right? And what has been happening, it's already been a few decades, but especially the past 10 years with the third wave of AI brought by modern machine learning, is that this box has become more and more opaque. And this is because of the advances on modern AI, specifically machine learning, and more specifically the role of artificial neural networks of considerable size and complexity, also known as deep learning. And we know that this in turn has been unlocked in some way by availability of data at scale and computational power. And at the end of the day, one way to describe it, the way I like to describe it, is that this new era is a new paradigm of automation where we start automating the automation. And that has several implications. On the one hand, some mind-blowing capabilities that were unimaginable up until only a few years ago, but at the same time, everything has a price. So when going from a deterministic approach to a probabilistic approach to problem solving, a few things need to be taken into consideration, especially when we're building products and experiences that leverage AI technology. And many of you out there might have done some machine learning without even knowing it, but in its most basic expression, if you ever fit linear regression to some data set, technically speaking, you've used machine learning in possibly in its most basic form. And for me, the beginning of the journey in data science in general and predictive systems started almost 15 years ago, where I started working on traffic prediction systems from some credit card companies, doing time series analysis and a whole bunch of stuff that today we call data science. And that piece of work is available online somewhere for those interested. So when it comes to solving problems, whether it's in audio or any domain, the dilemma of should we go for a clear box approach or a black box approach? And the answer is there's no right answer. It really depends on the type of problem. It really depends on the constraints of the under which we're operating, based on the kind of value that we're trying to unlock, based on the kind of product that we're trying to build. So it really depends. And I like to show this apparently simple example. This is like a homework during my master's from 10 years ago. Like we were forced to basically solve OCR, optical character recognition, with a clear box approach. And very soon something that's, may seem like it's relatively simple becomes extremely complex when you try to solve it with the rules. There's a ton of different steps, and each of them, has its own shortcomings. And when you start pipelining different processes together, you end up with something extremely complex. And this is, what you can also call old school feature engineering. So it can be a lot of fun, but also a really bad way to solve certain types of problems. And in this case, you end up building your own decision tree based on the rules and your understanding of the system, as I was mentioning at the beginning. And no matter how much time we spend on something like this, the system will not be robust, especially because it's a noisy problem. Think about handwritten digits. So having a system that can really bring robustness and predictability is extremely hard with that approach. So there's lots of problems and lots of data domains that are inherently noisy, that you could describe them as noisy, and audio and music are not the exception when we're trying to build AI systems. So imagine going from just simple OCR and now suddenly someone tells you, I want you to take this picture and write a program using a clear box approach that identifies all the text, extracts what the text is saying independently of perspective, lighting, occlusion, and so on. So if you ever come across a problem statement like this, I suggest you just quit, because it's gonna get ugly very soon. So for these type of problems where maybe a more black box approach is more appropriate, at a very high level, and I'm making an oversimplification of what's happening, going back to this idea of linear regression, and imagine that now you have thousands or hundreds of thousands or millions of hundreds of millions of these equations where the coefficients are learned automatically from data instead of being derived based on our own human observations of the system. And a lot of this stuff is not new. Convolutional neural networks have been there, almost 40 years now. So a lot of this stuff is not new, but in terms of the conversions of applications, data, computational power, the past 10 years have been really revolutionary in terms of the complexity of problems that we've been able to solve that only a few years ago would have seemed impossible. So this phrase, I don't know, one can have different opinions, but in a way AI is really a new paradigm of software and a really, really powerful one. And with that short intro and talking about impossible problems, my journey at the intersection of audio, music, and ML started like 10 years ago. While I was doing my master's at USC, one day I had this sort of realization, which is obvious but not obvious at the same time. And for anyone out there who enjoys music, either listening or creating music, it's a very historically asymmetrical thing. There's some people that create the music, they mix it, they deliver it in this sort of a black box, stereo format, and then for the passive listener to enjoy what was put together on the left side. So one day, sort of random, but I had been thinking about this, I asked myself, is there any way that I can go backwards? What if I took a mix and try to recover the underlying components, which is a problem known as audio source separation. And it became kind of like my research topic during my master's, and I almost became obsessed with this problem. And there's a nice history after the fact. A spin-off that I built was called TuneSplit, and this is kind of like at the end of the journey. The technology that me and my team developed now almost 8 years ago did. It could take any song and extract the vocal. It goes on and on. Is the audio coming out okay? Yes?
Yep, all good.
All right. So this is a very complex problem. So I'm gonna illustrate a little journey. So where do we begin with a problem of that kind of complexity? So what if we gave it a shot at solving this with a clear box approach, which is the way I started. And so if we want to understand the domain and what's happening, I can start analyzing, the waveform representation of audio. And I can start, analyzing maybe the envelope, try to see what's going on. And kind of like the question becomes, if I'm trying to isolate vocal content, where are the vocals in this mix? And obviously with this representation in the context of a mix, it can be quite challenging or even impossible. I can zoom in, I can try to find the vocals there, but likely I'm gonna fail miserably. So starting with this idea of understanding the domain, this domain knowledge is what allows me to start, with a clear box approach and really keep pushing and see how far I can get. And one of the things that we do in signal processing in general is to use mathematical and statistical techniques to analyze, transform, synthesize the information with certain objectives. And in this case, we know from that domain that there's more than one way to represent this audio signal. And while a plain waveform is not that interesting for this specific problem, we know that maybe using the Fourier transform, I can expose certain patterns that were not as obvious in the original representation. So in this case, I have the magnitude short time Fourier transform of Set Fire to the Rain by Adele. And once again, based on my domain knowledge about speech processing and all that, I can start figuring out, okay, maybe I can derive a set of rules, because I know that, human voice features a fundamental frequency that describes the frequency of vibration of our vocal cords. I have a different type of sounds, fricatives, that are not produced by vibration of our vocal cords, and I know that there's a number of harmonics on top of that fundamental frequency, deformants of speech that give each of us the quality of our voice. So what if I try to build a system where, okay, maybe I can start identifying vocal sections from sections that don't have vocals? This is a very old problem called vocal activity detection with background in communication. Maybe with that, I can build a small classifier with some heuristics that allows me to differentiate between the two types of voice. And maybe, I can also detect the fundamental frequency. There's many techniques out there that exist. And maybe with that, I can apply some sort of harmonic mask and somehow extract, by applying that mask, extract the vocals from the mix. And that was the first approach that we followed. And this is kind of like the output of that approach. So more or less, but not really there, right? And we're talking about a single vocal there. So going back to these problems that become exponentially more complicated the moment you start, not adding complexity, but dealing with the real world data, this approach falls short, very, very fast. And in this case, what happens when you have multiple vocals? Okay, this should be a video, but it's not playing. But anyway, when you have multiple vocals, forget about this idea of detecting the fundamental. It becomes a mess, and you can see it in this magnitude spectrogram here. There's like 4 or 5 voices, and that's where when things become really complicated. So at that point, we were like, okay, let's see if we can go the black box approach and see how far we can get. But what was important is that you don't need to swing between clear box and white box approach. There's some grace in between, and that's what this is mostly about, how to find the right balance and trade-offs between the two approaches. So inspired by, at the time, some of the advances in computer vision, we ask ourselves if this is possible, neural net, AI models that can learn to colorize images, that they can deblur images, that they can do super resolution, and you can think of these problems as kind of like reverse engineering problems. If this works, why could we not think about music, in this case, as an image, using one of these representations, in this case, the magnitude short time Fourier transform. So because this problem was originally pretty challenging to solve, we started with some baby steps and to try to validate some core principles, first principles that upon which we could extend to get to the final objective. So we started with let's figure out if we can detect vocal activity in music. So we're talking about basically a binary classifier. And the way we designed this was, okay, we want to analyze with very small resolution whether there's vocal content in this segment that we're going to extract from the audio. So we want a good temporal resolution, but at the same time, because music is time series data, there's temporal dependencies, we need to provide some context around the prediction space to have the model be able to do this robustly. So what we ended up doing is designing a feature space that, given some context, would be able to tell whether the middle frame contain vocals or not. So these details are not that important, but this is what part of what feature engineering is about, and it's how you represent the data even before you put it through a machine learning algorithm so that it learns a certain task and derives into a model. And again, this started as a binary classification task, and very soon we realized, oh, this is a valid approach because we got like 97% accuracy on our test set. And back in the day, and this is 2015 basically, it was a lot of fun to start discovering the effectiveness of these CNN networks, and it was really fascinating at the time to see how trying to inspect and debug what was going on inside the models, and how the model basically learned how to discriminate or came up with filters that knew how to extract vocal content or filter out vocal content or filtering out music. So from there we basically said, taking this binary classifier as a starting point, can we now go all the way to source separation? So in a way, we're trying to go from a classification problem to a regression problem. And the original design was, okay, let's give this model a chunk of the music at the input, and let's see if it can fully recompose the magnitude spectrogram of the vocals only. So pretty soon we realized that was too much to ask for that kind of model. Going back to the idea of constraints, these had to run in real time on a PC and share the GPU with some other rendering engines. So this was a highly constrained environment to try to solve this problem. You'll see that this model ended up having only 300,000 parameters, which is pretty low for given the complexity of the task. So we started getting creative. Okay, how can we try to frame the problem differently so that it seems like it's more simple than it really is, while still achieving the original objective. So we started playing with some heuristics and came up with an output feature space where we would oversimplify the task as this magnitude spectrogram representation as only allowing vocal or non-vocal content at each time frequency or each frequency bin, which is obviously far from reality, but at the end of the day, it kind of works. So we came up with this idea of these binary masks. And instead of asking the model to predict the full magnitude spectrogram, we asked the model to predict ones and zeros only. And with that, we could then apply this mask to the original representation of the magnitude spectrogram of the mix, and somehow rescue the vocal from there. And that's kind of like what we did, and it worked really, really well. And eventually we moved from, instead of doing regression on this binary space, which doesn't make full sense, we started treating this as a multi-label classification problem, which was very cool, and it did the job. So this is an example of kind of like bringing the best of the clear box and the black box approach to come up with an efficient solution that works. And in this case, we effectively converted this regression problem into a classification problem. And this is the original design of the model. It's actually very, very simple convolutional architecture. And don't worry too much about the details, because at the end I'm going to share some writings that I did on Medium a while back, and you have all the details about this work. Training data, which is always painful if you don't have an out-of-the-box training set. We spent months building this data set, conform of original mixes and the corresponding acapellas, and write a whole bunch of automation to automatically align them. And we ended up with a model that was trained on 15 million examples. And then we didn't stop there. Eventually, we said, okay, if this is working for vocals, chances are it might work for other instruments. And we built the first model to do source separation at the stems level, and it basically, in a single pass, could isolate vocals, drums, bass, and others. So we were not the first to do this, that there had been some prior art, but doing it in real time with such low number of parameters, it was a pretty big, significant contribution. And again, we're talking 2015, 2016. And we have some alternative designs for the stems model. Each of them had its pros and cons. And this is an example of that final model that could do stem deconstruction. Okay. I'm not sure why it's not playing the video now. Anyway, we're going to show, I'm going to share some of these things later. They're available as part of those articles. And in a nutshell, this ended up being a spin-off from that research at USC, with a vision to empower everyone to be part of and become an active part of the music creation process. It was called TuneSplit. Ended up having a small exit to another company, but it was a little ahead of its time. And today, 7-8 years later, you see these kinds of products. And Moses AI did something very similar. Back in the day, it was a little early, not only in terms of the readiness of the technology, but the readiness of the industry to embrace some of these ideas. But it's been very satisfying to see that these early ideas caught up, and now there's a lot going on in the space. And eventually, it's interesting how things went full circle, because eventually what we were trying to do is not just separate music just for the sake of it, but the idea that any person eventually could grab parts from different songs and recombine them, and making remixing accessible to anyone. And in a way, that's sort of what we ended up doing at Splice with CoSo by Splice, which I'm going to cover in a minute. In terms of the value prop for the end user, ended up being something very in line with this. So yeah, it was a really, really interesting chapter with TuneSplit. And then fast forward a few years, I joined Splice in late 2017. So it's been 5 years and something. And it's been an incredible ride. And at this point, I need to switch to another document. So the Splice chapter, and very quick, what Splice is about. Splice empowers music creators everywhere, and today is kind of like leading player in offering the building blocks for music creation out there. And the kind of like the core offering of Splice, we have Splice Sounds, Splice Gear, and Creative Plans, and Splice Sounds is the marketplace of sounds, which has always been the flagship product, but there's a lot going on now in how we're going to evolve that value proposition with AI playing a key role in that. So when I joined, something that was very important is kind of like define a strategy for how we would go about applying AI to audio and music, or what would our music AI strategy be. And it was very important to keep in mind that we're successful when our customers realize the joy of making music. So keeping human decision making at the center was always critical, and that really not only affects in the way you design interfaces and UX, but it goes all the way back to how you build technology that's compatible with this goal, right? Very holistically, when I joined, the question was, does it make sense for a company like Splice to have, an applied research in AI operation? And the answer was yes. And what AI could do for a business like this was, on the one hand, accelerating the process of discovery, or the mechanics of discovery, and on the other hand, accelerating the creative process. What are those fundamental problems that creators face when trying to get started, or making progress, or finishing music? So these have been kind of like the core two areas in what the past 5 years have been about. So at the beginning, we started with a lot of classification problems. We really were focusing on how can we automate and scale our content library. And we did a whole bunch of things, and we started with a supervised approach, building some audio classifiers. These are some of the original designs, and they work pretty well. And what these classifiers enable were, on the one hand, is bringing consistency to the tagging. As we know, audio is a lot more subjective compared to images, so describing audio is inherently challenging. So having a model that could, even on a relatively reduced class base, predict what the content was about was pretty useful for that consistency. And also this complemented our ingestion pipeline, and having kind of like a human-in-the-loop approach, where the people who ingested content could rely on the model to try to accelerate the tagging process. And for this, we use pretty simple convolutional architectures with different approaches for performing multiple predictions and coming up with a final answer. And this worked pretty well. But eventually, we realized that the supervised approach had many limitations, especially in the context of this massive catalog with lots of tags, where not all of them could be learned by an ML model, or it didn't even make sense to automate that. So between that and also new opportunities that we could offer our users to discover the catalog in different ways, we started going the unsupervised route. And this led to our first user-facing feature, which was similar sounds. And in this case, we started training these autoencoder models that could come up with really high-quality embeddings of the audio data in our catalog, and really dynamically capture pitch, harmonic profile, temporal structure, the semantics at times. And in a nutshell, what we did is design a system that, given any sound from the Splice catalog, it could retrieve the most similar sounds at scale in milliseconds, and where the context or the concept of similarity is relative, and it changes based on the inputs. So something very difficult to approach using a clear box approach, or even a supervised learning approach. And this ended up working extremely well. It brought a lot of value to our users. It increased conversion. And this feature is currently available on the website, and I'll show you exactly how it works. So you can go to any sample in the Splice catalog. And I have this little button here that says show similar sounds, and it will just display the top 10 most similar sounds in the catalog. check some other examples. Anyway, I love to use it with drum patterns, but it works with any sample from the catalog. It works with vocals, works with anything really. What was super interesting also, the core technology, we also deployed it internally to create a near duplicate content that makes it to the platform. And it also brought a lot of value during the pre-ingestion process. So even before a given sound makes it to the Splice marketplace, we run this internally to see if, for whatever reason, some of that content was a derivative of someone else's content. So it was an extremely valuable investment. Going back to the idea of accelerating discovery, accelerating creation, we also invested in a few experiments and projects on the acceleration of creative workflow, some generative AI back in the day, like this network that learned how to come up with new drum sounds. So none of these sounds exist. What you just heard were completely created by an AI model. It was inspired by the style GAN 2 architecture and trained on a good number of drum sounds from the Splice catalog. Some of the other stuff we did around timbre transfer, basically taking any sound from the Splice catalog and trying to re-render it with a different target instrument.
I can show you what love is supposed to feel like.
Some other interesting stuff where you can bring the best of both worlds. In this case, we used this generative model that came up with new drum sounds, but instead of exposing that with the idea of, okay, now as a user I can create new sounds, using that to kind of like express what your intent is. Like, I designed this new sound, and part of the work that we did here was figuring out how to control the latent dimensions of this model so that you could say, okay, I want a drum sound of this BPM, this kind of density on the kicks and stuff like that. And we hooked that up with our similarity search technology to try to find the most similar human-made sounds available in the catalog, and it turned out to work really well. And this is an example of that. And anyway, and fast forward, what was like 3 years in, we started realizing that Even though all these things were cool, and some of them actually ended up in user-facing products that create a lot of value, the idea of investing in accelerating discovery and accelerating creation as two separate, disconnected states was not going to take us that far. So 2 years ago, we came up with a strategy that I called discovery-driven creation, where the idea would be to develop not only technology, but a new way of thinking about the UX and interaction design between our users and the catalog, where now you could seamlessly jump between the states of discovery and creation. And that strategy gave birth to COSO by Splice, which is a new technology and a new product that we put out there, and a really valuable foundation on top of which we're developing some really interesting stuff that's going to come out in the next few months. And without revealing too much, this technology that we created is not that different from similar sounds. We figured out how to project our audio data in some latent space, going back to the idea of latent spaces, where we can compare sounds, and the system can tell us, how well those sounds will fit together musically. And what's really interesting is that it can be parameterized at the same time. So given a reference sound, I can tell the system I need a funky acoustic guitar for a hip hop track, and in milliseconds at scale, the system will tell me this is the most compatible acoustic guitar that fulfills that criteria for that input sound. And not only that, the technology can search across tonalities, so you can find sounds that are not even on the same key. And this does not implement any music theory rules or heuristic. This operates in a completely unsupervised at a layer below music theory, which makes it really, really powerful. So the COSO system can tell you this is the best, most compatible guitar, but you need to tune it down 2 semitones and stretch it by this percentage so that it matches the original reference BPM. And what we did, actually, the vision came for this product first, and then we went backwards and developed the technology. But eventually, we wanted to build this mobile surface that's we describe as a inspiration engine, an idea starter, something that, given some intent, currently in the form of these templates, it comes up with original ideas that just sound really good. And more importantly, because it's very important to keep the user at the center and on the driver's seat, we developed this very simple mechanics to fine-tune these results. So when COSO gives you a starting point stack, a stack is the initial 8-byte arrangement that you see on the second plot, you can swipe right on any of the layers, and the system will bring you the next most compatible sample from the Splice catalog that fulfills the constraints of the style and all that. So it's been a pretty cool project, and yeah. So if you haven't downloaded it yet, here's the URL. It's pretty cool to play with. We don't need to go through that one. That's a promo video. And what's interesting is that we have our own philosophy and way to deploy AI technology and AI-based product. And in this case, we're combining a number of things. On the one hand, unsupervised content-based retrieval, which is also the case with the similarity search technology. But we're also bringing parametric search so that we can customize that content-based retrieval system. And the idea of multimodal intent, which is something that I'm personally very interested in, and I believe is the future of some of these AI-first products. And by that, I mean the different ways in which you can query a system. We see a lot of that currently, obviously, with the large language models using natural language as the mechanic to manifest intent. But intent can be in any form, especially with music. It could be a description of what I want, and we've seen that with the latest from Google, Music LM or Harmony. But it could also be in the form of a reference song that I heard on Spotify, and I'm like, oh, I want to create something in line with that in that neighborhood. So there's a lot to be explored around ways to capture intent. What's really cool about this technology is that is very extensible, and it can also work with MIDI. It's not limited to audio. So we did some cool experiments where now we're asking the system to give us good chords, chord progressions for a musical idea. So this is the guitar solo that many of you probably know, and Coaster in this case will create good arrangements to support that solo. And this is the top arrangement that the system came up with. Here, the second one. And it goes on and on forever. How about remixing a song? Here, why not combine some of the work on source separation and use the isolated vocals from a track as the seed for the COSO system? So here's the output of the source separation model. And once again, here I can give an instruction or a prompt, if you will, to the COSO system, asking for a song section that contains guitars, keys, and claps in the percussion. So you see that here, even though the system is not generative, like these days it seems like everyone's talking about generative with reason, this is a different approach where we can almost emulate or replicate the same mechanics of these generative models, like providing a natural language interface. But in this case, rather than synthesizing the audio on the fly, what it's doing is matching human-made super high quality content in an intelligent way, so that no matter what you do, the arrangement will always sound musical. And that is an extremely good unlock and accelerator for creators. So when it comes to our approach to AI, at Splice specifically, and a big part of what I care about when it comes to AI, using AI to empower creation, in this case, rather than investing straight into generative stuff and all that, we try to unlock new layers of intelligence to serve human-made content more effectively. And the result of that first strategy gave birth to things like Similar Sounds, the first recommended for you system that Splice had, and COSO by Splice. And in addition to that, we can also invest in AI to extend the sonic boundaries of human-made content. And the stuff that I showed earlier about like timbre transfer, it falls under this category. And should we invest in fully generative stuff? Remains an open question. We've done some validations for that. But for now, It's really is our goal and mission to continue empowering creators through human-made content, and where AI can serve that content very well. And just to wrap up, what's next? There's for Splice, we are embarked on a mission to transform this amazing marketplace of sounds into a music inspiration engine. So in the next few months, you're gonna see lots of really cool things that are gonna be launched. And this is my personal assessment of what's next in general, not specific to Splice, but in terms of the kind of interfaces that we're gonna see that are powered by AI. The idea, again, of multimodal input, where rather than me having to adapt to the system adapts to me, and I can manifest what I want in multiple modalities. In natural interfaces, from 0 to 1 in seconds, the idea that I can, given an intent, I can get started with something that is good enough. And more importantly, when trying to keep humans at the center of the decision-making process, fine-tuning mechanics. And that remains a pretty big challenge when building AI systems. There's different approaches like conditioning and all that, but that remains an open issue. Being able to be very granular in how you control an experience that's powered by AI is not an easy thing. And that's pretty much about it. And I had one last closing statement to kind of like philosophy for how to approach problems when it comes to so going back to kind of like the dilemma of clear box versus black box, and one versus the other, the answer is, in my experience at least, especially on the applied side of things, you don't want to make them compete. You want to bring the best of both worlds, and it's a trade-off. And trade-offs are at the heart of any successful product. And in this case, the trade-off is, if I go black box approach, I have less understanding and control. It's harder to fine-tune and debug things. But at the same time, we can learn some incredible features that are beyond our understanding or ability to model. On the other side of the spectrum, I have more understanding and control. It's easier to control and fine-tune and tweak my system, but we are limited to what we understand as humans, or what we can model or make sense of. And with that, for those interested in getting more details about this design around source separation, I published a couple of Medium articles with lots of details there. And this last one, what is the main reason most ML projects fail? So for any of you who are thinking or already working on applied ML to try to build products, highly recommend that one, some lessons from the field. And that's all I have to say.
Fantastic presentation, Ale. I'll give a couple minutes for anybody in the chat to ask any questions. One question that I had was, how big is your team? How big is the is your team that you work with?
Sure.
Or is it just you? Or is it just you that did all of this?
I could never make all this happen by myself. But we do have a pretty small team. I like to think that we have a very efficient R&D operation. Currently, we are 4 people as part of the core ML team. But when you see things like Coso the app or similar sounds, when it's time to build an actual product feature, then it becomes a broader team that's much larger, and a partnership between our team and the audio apps team and SRE and backend and front end. So, but yeah, the core team doing applied ML research is pretty small.
That's amazing. And how do you, when you when you find members for your team, what do you typically look for? Do you look for people that have already had experience with in large data sets? How do you decide? How do you
It's a good
find
fit.
somebody and say this is somebody that's right for our team? I'm just curious.
I like the question because what I care the most is good decision making. People who are, and good decision making comes from mostly just common sense and being very pragmatic when solving problems. And especially in this area of ML and stuff, it's very easy to fall for guilty pleasure stuff. Oh, I want to do this because it's super interesting in school. So it takes being very intentional and very customer centric and product driven to make the right calls. So that's one first version of the answer. And just to support that, when you're doing applied research, you operate under really high levels of uncertainty. So it's very easy to get lost. It's very easy to end up on a rat wheel and start going around in circles. So really what I look for and what I think is the key to succeeding in applied ML is being very actionable and really making good decisions even when you don't know what the right call is, which sounds a little contradictory, but hopefully that makes sense. Obviously, people who have good domain expertise, but personally, I wouldn't trade unless there's something extremely specific that we need to unlock or accelerate. I care more about decision making and being able to navigate experimentation, which I believe is a whole discipline in itself, versus the specific skill set that you bring. Hopefully you bring both, but it's rare.
That's awesome. And this has been a discussion that I'm sure you've heard about, but with the amount of content that Splice has and the things that you're able to do, like you were saying, it sounds like at the center of the mission is making decision-making human-centric. How do you keep yourself from the temptation to say we don't even need producers to create drum kits anymore? We can just generate these ourselves and just.
Well, I mean, there's multiple answers. First of all, I'm also a creator. I'm also a musician, so I can definitely relate with what it means to be a creator. So I care a lot, and I definitely embrace the mission of empowering more creators. So that makes it easy. And the second one, it's part of my job. For me to be successful and responsible in my role at Splice, I need to be very intentional around the strategies that I deploy. And for a company like Splice, that is the right approach. That's what we need to do to make Splice successful. Do I get tempted about trying more end-to-end stuff, especially with the data set that we have? Sure. But to be clear, we do sometimes when time permits some internal R&D to be on top of all the stuff that's going on, even knowing that certain things will not end up on a user-facing product. But as I showed, examples where you can bring the best of both worlds, right? So like the example that I showed where you have an end-to-end generated model, but instead of giving that generated drum kit back to the user, we use it as a way to manifest intent, to capture a query and surface human-made content. So you can get really creative with ways to also combine different AI models, but yeah, that would be my answer.
Nice. And do you have when you think 3 to 5 years down the line, in terms of what a creator looks like, what sort of tools that they'll be using, what sort of tools musicians will be using, what vision do you have?
Well, I guess the first answer to that is what I showed towards what I shared towards the end of the presentation. I consider it a new paradigm of interfaces. So it's not just about AI, it's a convergence of AI and just a new way to think about interfaces, where again, you have multimodal input and natural interface, so with a very short learning curve, and the ability to get from 0 to 1 in seconds. Like when you think about music production, and just like many other things out there, it's not a mystery what makes a decent sounding track sound well. Like the rules of songcraft are widely known, the basics of maybe EQ mixing, and yet when you open a DAW, you start from scratch. So some of the interfaces are already obsolete in that sense, and we currently have technology that could solve some of those 0 to 1s. And fine-tuning mechanics, what are the ways, when you think about something like COSO, with a single swipe, you can change your arrangement, and it can be directional. That, I don't know if that answered the full question, but one way to answer it, products like COSO to me fall under that new category of creator interfaces. And obviously for us, that's not the end. We're going to be building more and more stuff. But zooming out for a second, I think we're moving into more web-based stuff that is collaborative by design. When you see things like Figma or Canva, what they've done in the design world, I think we're all waiting and actively chasing what the equivalent or the music production version is going to be. And there's some players out there that are like giving it a shot. I was looking at the other day, I was watching what the guys from Never Before Heard Sounds are putting together, this kind of like Figma-like interface. So I'm not sure if that is the future, but it definitely validates some of these core principles that I can relate to. Mm-hmm. So yeah.
Yeah. Do you think that that the technology will move us away from the traditional DAW timeline-based grid system, or will that still remain in play just with some extensions to it?
Mm-hmm. I think that's a great question, and I don't think it's like, oh, is it going to be A or B? I think the first question is, who are you building that for? I think that's the key. I think the DAW is going nowhere for certain type of creator and use cases. When you're trying to, create a radio-ready Billboard Top 100 song, I mean, there's a lot of good complexity that can go in and a lot of granularity that you want and you need. So trying to replace the full extent and the full power of the DAW is a really long shot and a very risky one that I wouldn't sponsor. But I do believe that as powerful as the DAW is, it also presents lots of technical and psychological barriers for people who are not as comfortable, and especially people who are maybe beginners in music production, and especially for people who've never made music before. So I believe that's where the biggest opportunity is, interfaces that are more current, where you can get started in seconds with a very short learning curve. And I think for some people that might be enough, and there might be a new generation of services where some people don't ever get to the DAW because they have enough. And in the best case scenario, people who are somewhat confident with the DAW or proficient with the DAW, they're going to benefit also from AI technology in the form of either some sketching interfaces. Like in COSO is a good example of that. Like the COSO mobile app, you can, when you come up with something good, you can click a button and export that to an Ableton Live session and continue in the DAW. So that's an example of integrating things. And it could also come in the form of a BST plugin that's constantly aware about what you're doing in the DAW, and it really accelerates the process for you, surfacing relevant recommendations and so on. So I think it's going to be a bunch of things, and companies are going to have to be very aware and intentional around who are you building that for, because there's going to be no silver bullet of product that works for everyone.
Right. So it sounds like maybe the focus could be more towards more focused tools rather than a all-in-one solution like a DAW, from what you're saying, because there are going to be so many different workflows, and it could be about the integration of those different workflows rather than just an all-in-one solution.
Yeah, that's what I think. I mean, I wouldn't discourage anyone who's like, oh, I'm going to solve this. Chances are you're going to fail, but if you get it somewhat right, you could do very well. Right? But I don't know, maybe I change my mind eventually, but at this point, I think it's still a pretty long shot to think about one single next generation interface that's going to solve everything for everyone.
Absolutely. Looks like our listeners, watchers, viewers have run out of questions. A lot of positive feedback. Thank you very much, Ali, for sharing your insights. That was awesome.
My pleasure. Thanks for having me.
Great. And Adam has had to sign off a little bit early. It's starting to get a little bit late over there in England, where Rachel is as well. So
I'm still hanging on.
Still hanging on.
Yeah.
Staying strong. Thank you. Thank you very much to everybody who's tuned in and who's hung on for the meetup. I'm now doing what I do every month, which is looking at what our next date is. So it looks like it's going to be the 14th of March. 14th of March. Normally we do it every second Tuesday of the month. I made an exception this month because next Tuesday is Valentine's Day, and if we have partners, then like myself, then they want, of course, to do something for Valentine's Day. So just moved it back a week, but 14th of March is the next date for our next meetup. Thank you to Adam, Rachel, and Ali for joining us. Thank you again, Rachel, for co-hosting. It's been a good time. So I think this is nearly coming up on 3 years of the audio programmer meetup. So yeah.
Really?
Yeah, staying consistent. Yes. So with that, we'll go ahead and sign off. Thank you very much to everybody who's attended, and we hope to see you next month. Oh, by the way, we're going to be doing a live stream tomorrow. I'm going to be doing a live stream with Martin Mistrowski Woods. We're going to be talking about everybody's favorite thing in plugin development, which is plugin state. So just synchronizing threads, synchronizing what's happening in your user interface with what's happening in your data model, different ways that you're able to do that, and different ideas and concepts behind it. So if you're around at about 2:30 Eastern Standard Time, we'll be online and we'll be talking about all the fun things about plugin state. So join us tomorrow. With that, we will sign off. Thank you very much, and have a great morning, afternoon, evening, everybody.
Thank you.
Thank you, everyone.
Cool.